I thought that was my last one on the graphs. I had a 3.3 paper that got snuck into 3.2 though. So on this one, we do our vertical line test again. This would be a function. Our domain and range, so our lowest x to our highest x, and since there's arrows on both ends of this, our domain, so domain will be negative infinity to positive infinity. And then our range is going to be our lowest y value, which is going to be this -4. And we put a bracket with it because it can't equal that point right there. And then it's going to go all the way up to positive infinity. Our intercepts, I have one here, here, and here. So my intercepts would be, this is 1, 2, 3, 4, 5, so 0, 5, 1, 0, and 5, 0. And then symmetry, since this isn't over here at the y-axis, the x and y-axis, the origin, it has none. Okay, that's the end of those. So the last bit of section 3.2 is answering questions using this function notation. So they start off with, is the point -2, 9 on the graph of f? And they give us this function here. So I'm going to take this, and remember on these that this is x and y, and that f of x equals y, so I'd have 9 equals 2, and I'm going to substitute this -2 in, times -2 squared, subtract a -2, subtract 1. And I'm not going to do anything with this 9 over here. I'm going to work this out and see if it actually equals 9. So 2 times -2 squared is 4, subtract a negative, so plus, what did I put? 4 plus 2, subtract 1. So 8 plus 2, subtract 1, 10 subtract 1 equals 9. So yes, because substituting x equals -2. If x equals 2, f of x equals blank. So on this one, they want us to substitute a positive 2 in to this equation. So I'm going to write that over here. 2 times 2 squared, subtract 2, subtract 1. So 2 times 4, and I'm combining these two, subtract 3, 8 subtract 3 equals 5. And then they want us to write this in an ordered pair, so my x was 2, my y was 5. Now they give us this f of x equals -1, so that means y equals -1. So I'm going to have -1 equals 2x squared, subtract x, subtract 1. I'm going to solve for x's, so add 1. So, oh, I don't have room over here. 0 equals 2x squared, subtract x. Then we'd factor out an x here, so x times 2x, subtract 1 equals 0. So I have, one of them is x equals 0. And then this would be 2x minus 1 equals 0. Add my 1. 2x equals 1, divide by 2. So x equals 1/2 and 0. So up here I'd have 0, 1/2. And then when I go to do my ordered pairs, these are my x values, these are my y values. So I have 0, -1, and then 1/2, -1. What is the domain of f? So the only time our domain is going to have restrictions is if we can make it undefined or not real. This is just a quadratic equation, so this one is fine. Our domain is going to be -infinity to infinity. The next one is one that I can show you where there's that exception. List the x-intercepts if any of the graph of f, select the correct choice. So remember, when we're finding intercepts, we substitute 0 for y if we're solving for x, and 0 for x if we're solving for y. So on this one, the x-intercepts, we're going to have 0 equals 2x squared, subtract x, subtract 1. So let's change this to x, x, 1, 1. One's going to be negative, one's going to be positive, so negative here, positive here, because that'd be negative 2x plus 1, which will give us our negative x in the center. Y'all can't see that, I apologize. Then we'll make them both equal to 0. 2x plus 1 equals 0, x minus 1 equals 0. So 2x equals negative 1, divide by 2, x equals negative 1/2, add 1, x equals 1. So our x-intercepts are going to be negative 1/2 and 1. Now when we go to do our y-intercepts, that one's very much nicer. So y-intercepts, we'd have y equals, and we're going to put 0 in for our x's, so 2 times 0 squared, subtract 0, subtract 1. So 2 times 0, 0, so y equals negative 1. And that's that problem. And I'll start a new video for the other one.